Hi, and welcome. This will be a quick demo and example run of the interface of my project, the Clinical Intelligence Copilot. Starting off on the far left here, we have the no-show risk calculator. Here we can fill in various fields of information on a patient and calculate their likelihood of the patient no-showing for their appointment. So for example, let's start off by filling out the fields. Let's say this patient is female, age is 42. We can put in what neighborhood they're from. We'll keep what we have here. We can also fill in any medical history on the patient. So let's say this patient has hypertension. You can also input their handicap level, let's say 2. This is the date their appointment was scheduled, and we'll put November 1st for that. And this is the date of their actual appointment, and we'll keep that November 21st. And if we run the model now, so a patient with this data set of information has a 36% chance of no showing for their appointment. We can also go back and add in various pieces of information and see how that impacts the model's calculation. So in this case, we'll add in that the patient has received an SMS reminder. And if we run the model now, so yeah, as we expect in this scenario, with the SMS reminder being sent out, it decreased the no-show probability percentage by about 2.3%. So that is a quick demonstration of the first piece of my project. We'll close that down and move on to the next piece, which is the X-ray image analyzer paired with the clinical assistant chatbot. So here we can upload an image of a patient, and we'll pick this guy here and run the model. And the model spits out an output based on the image we uploaded and gives us its confidence levels in each finding. And yeah, we can see that down here. And over here in the clinical assistant chatbot, the clinician or doctor can ask questions about the diagnosis or verify information that they may not be 100% confident on. And they can also ask for information about the patient if the chatbot is linked up to their patient medical database. So, for example, I have no clue what this is. So we can come up here and just ask the model what this is, and it will query the database and return the definition, as we can see here. And as I mentioned in my project description, I custom engineered the chatbot and the model to ensure that it does not answer questions outside of the database and knowledge that it has access to. So, for example, if we ask it something that isn't in the database, and of course, I always butcher the spelling of that, and we put that through the model, it will query the data. And yeah, as we can see here, it says, I don't know. So the LLMs of today are notorious for hallucinating and fabricating information, which is a big concern that a lot of people have with them. And in a regulated setting where you're diagnosing patients or dealing with people's lives, or in any other setting where facts are important, um, they're important in every setting, but in a setting where you have to be 100% certain on, the information, implementing a component where the model actually says I don't know is very critical. So that was a piece that I engineered into this model. And yeah, that was a quick example run. We have a few settings on the site as well. Uh, we can turn off or turn on wide mode, which optimizes the module's width here. We also have a dark mode as well, which looks pretty nice as well. And yeah, just as another example, we can also ask another question and see how the model responds. And yeah, so I asked classifications of pneumonia. So as we can see here, the model queries the database, which is hosted on Azure. And here we can see the various resource groups that I have set up. And when the model is asked a question, it performs a vector retrieval to pull the most relevant information from the medical knowledge database, and then synthesizes an answer using the ChatGPT 4.0 model. So yeah, that was a quick example run of my platform. Together, these three modules form the end-to-end clinical intelligence tool that unifies predictive analytics, medical imaging, and knowledge-grounded AI assistance. The goal of this platform was to demonstrate how machine learning and generative AI can work together to support healthcare operations and clinical decision support. The principles of this project can be applied to various other domains or various other processes. It's not just limited to healthcare operations. For example, anything where you require image analysis and you have a large data set of images, you can train a model and it will learn from the images and be able to provide an output. And you can engineer it to derive an outcome. And same thing for the custom chatbot. You can engineer them so that they work for your purpose. And same thing here, where you have structured data. You can train a model on it, and it will spit out an output based on what it learned from the historical patterns. So yeah, I hope you enjoyed that quick example run, and thank you.